they have this six-fold division of the globe into areas. And let's just look at Europe and North America first. You can see nuclear power has been or was coming up in the 1980s quite a lot, and was then up to about separately in Europe and North America about 120 gigawatts in 1990. After that, it has grown very little. But in the last few years, it has taken off again. So we are really seeing more nuclear. And you can also see this continuous growth for Asia and Oceania. Oceania is, of course, Indonesia. And Asia is really East Asia, including in India, and then Australia and New Zealand. So they have been growing steadily all the time, increased about 4 times in 25 years. That is quite a lot. The thing is, this is never in the news. So the news is really very biased with, certainly with energy resources. So now it is hydropower. And you can see in North America and Europe, there has been very little growth. There has been growth mostly in 2 places, again in Asia, East Asia. But also, if you can see these little squares where the curve has some slope, and that is Central and South America. So they have been coming up with hydro. And the numbers, they are higher than for nuclear. So we have more hydro to produce energy, electric energy. And then we come to conventional thermal, which is mostly coal, but of course it may be some oil, but mostly coal. And here you can see some growth everywhere, except one place, a huge growth. From 1980 to 2005, you can see Asia is going up from 200 gigawatts up to 800. And it continues to grow. This is mostly India and China using coal for electric generation. This worries the Western world and maybe more areas about global warming. They're really shooting up. But I had a good remark from somebody at Stanford University in California. Said, we need not worry about global warming. Before it becomes too serious, we will have run out of coal. And oil, of course. So this gives you a little bit of an impression. And now I have 2 diagrams. This is 2005. And then you can see conventional thermal is about 2/3. This is the pinkish color. Hydro is almost 20, nuclear is about 10. So you can see what are the energy resources for our electric power generation today. And then we come to geothermal, 0.23%. Nuclear is 1.9, it's some biomass, but it really is a large fraction of it is wind energy today. There is still very little direct solar. And I managed to scrape out numbers for last year, 2009, and you can see the numbers have changed. Nuclear has really come up. Geothermal is about the same. Hydro has gone down a little bit relative, and combustible fuels, all of them, fossil fuel and everything else, this is a newer classification, and this is still 60%. So we are mostly using combustible fuels and nuclear, raise environmental problems, and it is not going to be easy to convert completely to renewable energy resources. Now let's look a little bit at the second topic, geothermal resources. And what is geothermal energy? It really is just the heat that is stored within the earth. Of course, just about all of it in rocks, but some of it in fluids that are mostly meteoric or rainwater by origin that just seeps deep into permeable rocks, few kilometers depth. The basic thing with geothermal is we must have this fluid to transport the water, to transport the heat to the surface. So this is the medium that conveys the heat from depth to the surface. Now we have many types of geothermal systems, although no two geothermal systems are the same. But we see that they occur again and again in the same type of a geological environment. And it is this. I want to bring this forward because we are always trying to make some kind of classifications to be able to communicate better and summarize our understanding. But nature did not do that. We did. So it's not something that you should take as being something 100% right. It is just helps. But we have many types of classifications by many people who have different experiences or who have been working in different places, different countries. But the classification that I like is presented in Encyclopedia of Volcanology, 10 years old, and it covers pretty well the systems that we know of. And there are basically 5 types. We have systems in young volcanic environments. Of course, this is a long term. One usually just calls this volcanic geothermal systems. Then we have tectonic systems. Together, these two are hydrothermal systems. They are characterized by circulation to great depths, few kilometers, of groundwater. And in not all of them, but in most of these systems, likely, certainly the ones that we see, we have the manifestations of hot springs, fumaroles at the surface that really prove that we have a hydrothermal system.
Hydrothermal system as in you have water to carry the energy?
Water is circulating and it's carrying the heat energy up to the surface or to shallower depths. And then we can drill for it. We like to find permeable rock, so we can tap this water. So far today, these are the only systems that we can use economically and technologically. Then we have 3 more types. Hot, dry rock. It means rock that is not permeable. Sometimes people call these enhanced geothermal systems today. It means we want to exploit heat stored in the rock, and most, of course, of the heat within the crust of the earth is in hot, dry rock. So something like 20, 30 years ago, the idea developed, well, 30 years ago it is, can we develop technology to make use of this heat?